Good morning, I'm Carlos Racines, and today I'm going to talk about best PCB layout practice for frequency synthesizers. Okay, and first I'm going to talk about the definition. Okay, so let's go. First, a printed circuit board in the is a PCB. It currently supports an electrical connects electrical or electronic components using conductive tracks, pads, and other features etched from one or more sheet layers of copper laminate onto and between sheet layers of non-conductive substrate. And as you know, I'm gonna say the application. Okay, so printed circuit boards and electronics contribute significantly to the medical sector. Not only are they used in applications, but they are also used as monitoring, diagnostic, and treatment devices. The application of the PCBs for the medical sector is growing at a fast rate as technology improves, which leads to new possibilities. Okay, so some of the common applications of PCB are monitors and other devices that are very important and very useful for the doctors. Okay, and the pros and cons. Pros and cons. The first pros is space-saving conduct circuitry, and the second, directive printing legends eliminates the need for decoys. The last is integrated LED lights provide a glance verification of functionality. And the pros are first, initial design time and tooling required and difficult to revise multiple times. The last is high amperage can read the PCB. Also, you have to need to know that most of the devices actually have a little PCB, and for example, a control. And the conclusion. It's very important in all electronic gadgets which are used either for domestic use or for industrial purpose the PCB, because its design devices are used to design the electronic circuits apart from electrically connecting, and it also gives mechanical support to the electrical components. Thank you very much, and I'm going to share this video. It's to talk about the same topic. It's for the important and the use of the PCB. Thank you for watching this video. See you later.
So you just bought a shiny new motherboard, and after you're done oohing and eyeing over the heat sinks that say Extreme Gamer, that are designed to look like a battle axe or whatever, you might have noticed all those tiny traces on the board that connect all of your ports, headers, and sockets together and actually make the board light up and function correctly. And although they're not particularly exciting, traces on printed circuit boards or PCBs have basically made all of modern electronics possible. In fact, before they became widespread in the latter half of the 20th century, connecting every electrical component inside of an appliance looked a little something like this: a huge mess of individual wires. This is actually a look inside of a TV from 1948. I mean, imagine trying to build a computer or even buy a flat panel TV if you had to deal with that. Fortunately, the idea of embedding wires in a flat piece of fiberglass really took off as the years went by, making it possible to fit a PC in a backpack instead of a giant cabinet. But how exactly then do they pack so many important connections in such a small space? The process is actually somewhat similar to how CPUs are manufactured, which you can learn more about in this video, albeit at a bit of a less complicated scale. Slices of fiberglass are stacked together and treated with a resin that makes them stick to each other to make one solid slab. Then, layers of copper are applied to both sides and coated in a chemical called photoresist. After this, a pattern that matches up exactly to the traces that are supposed to go on the board is placed on top, then the whole thing is exposed to UV light. The board is then washed, which, well, washes away the uncovered areas, leaving tracks of copper. These tracks serve as a base for how the PCB will ultimately look after a couple of more steps, including etching additional copper and more washing. But keep in mind that this process is often done in layers, which is why it's a terrible idea to try and drill through your motherboard if you're having trouble mounting a cooler to it. The internet has more than a few tales of people that tried to do this, only to find out that their board didn't work at all afterwards because they drilled in the middle of traces that were visible from the outside, but went right through ones that were inside of it. But that isn't to say that boards don't get drilled at all during manufacturing. At the factory, boards not only get mounting holes drilled through them for whatever form factor they happen to fit in, but they also get small holes to accommodate connections for small electrical components like chips, capacitors, and resistors, as well as tiny interconnects between the different layers of copper traces. So after things like PCI Express slots, heat sinks, and CPU sockets are mounted or